Hello everybody! Today we're going to start... No, I'm not going to use an accent. This is finding the 6 trig ratios on the unit circle, alright? So we're going to use the angle 5 pi over 6. So 5 pi over 6, you guys know that it is 150 degrees. By now you've memorized that the coordinates are negative square root of 3 over 2, comma, 1/2. Okay? So we're going to use these coordinates to find all 6 trig ratios. Now there's 6 trig ratios. In the first section we learned sine, cosine, and tangent, SOHCAHTOA, right? Well, there are 3 more trig ratios. There's cosecant, secant, and cotangent. These we call the reciprocal trig ratios. There's not much thought that you need to give to these because they're literally just reciprocals of these ratios. Alright, so let's start with sine and cosine. Alright, now I'm going to arrange my work like this with sine, cosine, and tangent, and then I'm going to put the reciprocals across from them just for aesthetics. Okay, so the sine of 5 pi over 6. Asking about the sine of 5 pi over 6 is basically asking what is the y value at 5 pi over 6. Alright, so we look at it and the y value is right there in front of us. Right, it is 1/2. So I've got it right there. Sine of 5 pi over 6 is 1/2. We learned also in math 3 that how to find the cosine. The cosine is just your x value, right? So the cosine of 5 pi over 6 is negative square root of 3 over 2. Alright, which we have right here. Negative square root of 3 over 2. Those are the exact coordinates, alright, of that point. Now tangent, for tangent we have to start to think a little bit. Alright? Tangent we learned in right triangle trig is opposite over adjacent. Right? Well, here we're going to think of it very similarly. Sine divided by cosine. So there's an identity that says that tangent is equal to sine over cosine. The definition of tangent is sine over cosine. So that's something new that we're going to acquire. Sine over cosine is always tangent. So if I want to find the tangent of 5 pi over 6, then I simply have to find the sine ratio, which I already have, 1/2, and divide it by the cosine ratio, which I already have. Alright, so I'm going to take 1/2 and divide it by negative square roots of 3 over 2. Alright, this is very simple. I am dividing 2 fractions, so I multiply the first fraction by the reciprocal of the second. You'll notice your 2's cancel out, and I'm left with 1 over negative root 3. This is actually the tangent of 5 pi over 6, but it is not an acceptable format for you to write your answer. Alright, so to write your answer, you have to go through a quick process called rationalizing. So I'm going to rationalize this because the problem is I cannot divide by a radical. Alright, fractions cannot have radicals in their denominators. They may only have radicals in their numerators. So to get past that hump, you just multiply by the square root of 3 over the square root of 3. Alright, when I multiply my numerators, I get square root of 3. I kept my negative, I just kept it right there. Alright, in my numerator, it doesn't matter where it goes. And then square root of 3 times square root of 3 is square root of 9, or just 3. You can think of the radicals just canceling out. You're just left with 3. So the tangent of 5 pi over 6 is negative root 3 over 3. That was probably the most complicated of the 6. Okay? Moving right on along to your reciprocal ratios. Cosecant. Cosecant is the reciprocal of sine. Alright? So if your sine was 1/2, then your cosecant is 2 over 1, or 2. Alright? So all I'm going to do is take the reciprocal of my sine value. Alright? The definition of cosecant is 1 over sine. In other words, the reciprocal of sine. Okay? We've got secant. Secant is the reciprocal of cosine. So naturally I can just take this ratio and flip it. Right? So I've got negative 2 over root 3. I notice I've got a radical at the bottom. So once again, I have to rationalize. So I'm going to multiply by square root of 3 over square root of 3. And I end up with negative 2 root 3 over 3. That's your final answer for secant. Last, I have cotangent. Alright, my cotangent of 5 pi over 6 is simply going to be the reciprocal of my tangent. Alright, and I'm actually not going to just find the reciprocal of this, because if I do, I'm going to have to rationalize all over again. I would have a radical at the bottom. So you can actually trace back your steps, and you can see that at some point you had 1 over negative root 3, which means I can just find the reciprocal of that and get negative root 3. Now here I actually showed all the work. I did cosine divided by sine. Since cotangent is the reciprocal of tangent, tangent sine over cosine, therefore cotangent is cosine over sine. Alright? It is still just the reciprocal, so you get negative root 3. Of all those 6, I think tangent was the most complicated. Last thing I will say is, of these, it looks like sine and cosecant are the only ones that are positive. Every single other one is negative, correct? This is because this ratio is in quadrant number 2. Quadrant 2 has cosine values that are negative and sine values that are positive. Alright? Therefore, your sine will always be positive and its reciprocal will be positive. Alright? Sine is positive and its reciprocal are positive. Alright? If you are ever wondering which ones are supposed to be positive where, there's a quick acronym that you can remember. Alright? And that is A, S, T, C. A for all, S for sine and its reciprocal, T for tangent and its reciprocal, and C for cosine and its reciprocal. This acronym will help you remember where are the trig functions positive. All trig functions are positive in quadrant 1. Only sine and cosecant are positive in quadrant 2. Everything else is negative. That'll help you check your work real quick. ASTC, also known as Appalachian State Teachers College. Mic drop. There we go. Cut it off.